Yes, good morning, everybody, and good evening. I myself am in the Netherlands. It's 6 o'clock in the evening. Multiple participants of this webinar are in California, so we cover roughly the world. Welcome very much. This is the first joint webinar by ELAAD and the Californian Energy Commission on V2G. The idea started half year ago with a royal visit to California, to San Francisco, where there was a signing between our Queen and the wife of Governor Newsom on reaching climate goals together. This is, of course, a joint effort, and bidirectional charging, charge when there is a lot of sun or when there's a lot of wind, might be the holy grail for the energy transition to reach its climate goals. It all sounds very nice on paper, on PowerPoint, but what is it that we exactly need to do? And today we organized a panel with people from regulatory boards, Jeffrey Liu, from Grids, PG&E, a car manufacturer, Lucid, Sebastian, and also Lonneke Driessen, who is doing all the standards and protocols from a grid perspective. That's what we're going to talk about today. Feel free, if you have any questions, to state them in the chat, because after the presentations, we'll do a little panel discussion, and your input is welcome, your questions. So for now, I would like to give the stage to Lonneke Driessen. Lonneke, the floor is yours. You're going to tell something about standards and protocols from grid perspective. Go ahead.
Thank you, Baerte, and welcome everybody. Can you see my screen?
I can see it, yes.
Great. So I have the pleasure of kicking off this webinar on V2G with the first presentation. I first will discuss a little bit about the perspective of ElaadNL, which is an organization by the Dutch grid operators and transport system operator. And then I will go more into the standardization work and the work we do at the Open Charge Alliance on OCPP. But first of all, V2G, bidirectional power flows and grid codes. What is it? Why is it needed? And how can we combine the grid codes and bidirectional charging? So as I mentioned, I work for ElaadNL, which is an organization by grid operators. And for many of you who need to connect to the electricity grid, your charging infrastructure, you may think, well, how hard can it be? If you look at it from the surface, how difficult can it be to manage an electricity grid? But when you go below the surface, and in this case, literally below the surface, this is a picture of the electricity grid in the city of Utrecht. And you can see these guys have quite a challenging task to maintain and increase the grid capacity. So sometimes when you look at a problem from the surface, it's not so complicated, but when you dive into the details and dig down figuratively, it may be a bit more complex. So as you may know, ELAAD is a supporter of bidirectional charging of vehicle to grid for a long time. And we frequently and more intensively are getting pushback or feedback that the grid codes or the requirements from grid operators are quite challenging, they are diverse, and they may become an impediment to the rapid adoption of V2G. And of course, us being funded by the grid operators, we found that it was about time to dive deep into the grid codes. What are they, and what can we do to, as grid operators, to help them, help to settle these questions and move forward with V2G. So that's what we did. The work that we're doing at ELAAD is part of a broader EU Horizon project that started last year, in the summer of last year, and will run for 3 years. And this project is called Scale. There's a nice website where you can find more information. And the pilot project or the demonstration locations are spread across Europe, in France, Germany, Hungary, Norway, Sweden, and of course, the Netherlands. And what it is, one of the many things that this project is addressing is, first of all, an assessment of all the transport system operators and distribution system operators requirements for V2G, And of course, if this turns out that it's needed for the rapid adoption of V2G, to try to harmonize those grid codes, and also importantly, educate everybody to explain what it is and why it is so important. And of course, we are of the firm belief that once everybody understands what needs to be done, then everybody will be able to move much more quickly. So we've just started with this project, so we're not done yet, but please look out for the publication on grid codes and V2G later this year. But the one thing that were sort of becoming clear for us now is that we sort of can explain what the grid codes cover and why. So if you are a power generating module, that's sort of grid speak for bidirectional charging. So if you provide power back to the grid, it basically boils down to these 4 aspects. So because you're a generator, you are helping provide the grid frequency and the grid voltage. So you should adjust your behavior according to the grid frequency and the grid voltage. The second aspect is if you're a power generating module, you should listen to a direct stop signal in case that's needed. What's important that you continue your operation despite sort of grid hiccups. So the grid frequency and voltage is not very stable all the time. So sometimes there are spikes or dips or whatever. And it's important if you're pushing back power into the grid that you continue to do so and not be thrown off by slight variations in the grid, which normally occur. And lastly, it's important to detect if the grid is down. And of course, once the grid is down, do not feed into the grid when it's down. And when the grid comes back up, reconnect with care. So those are the 4 things that power generation modules should take into consideration. So the project firstly addresses France, Germany, and the Netherlands, but we've also included the United States of America because, of course, the great cooperation that we have and the importance the US industry and the US regulatory offices have, the big stake they have in bidirectional charging. But we are at the same time reaching out to more countries, such as Japan and Korea, and we're asking them, so what are your grid codes and can you help us complete the picture? Because of course, EV charging industry, but also car manufacturers, it's a global market. So it would be really helpful if we can provide the insight inside Europe, but also in other regions where EV adoption is accelerating. And of course, the aim of this project is to try to standardize, but also to build and to test V2G systems that are fully compliant with all these grid codes. So there are many ways as a utility or as a network operator that you can communicate and interact with power generating modules and transmit all the information that you want to according to the grid code. So of course, there is the option of directly communicating with vehicles using a telemetrics route. There's also, of course, an opportunity to connect to components that are located in the grid connection, so a direct connection from a utility to a charging station. And there's also a third route, sort of using an aggregator, or in this case, a charging station operator. So the utilities communicate to the charging station operator and they pass on the information and feedback the information through their already available connection. So for this presentation, I will limit also due to time to this method. So the utility communicates to the charging station operator and forward and backwards. So luckily there, as we've learned, there is already a lot of work that has been done, a lot of good standardization work. So we are looking to more publications. There is more, but basically these are the most important ones. The IEEE 1547, very clear and complete standard. The EN 50549, and also the specific requirements in France and in the Netherlands and in Germany. So we think that this is the first reason why there's a lot of confusion about grid codes, because it is true, there is a lot of documentation and you really need to find all the bits and pieces and what the status is. So the gathering of all the information is a bit of work. And of course, with our publication, we'll try to help everybody navigate that. But once you look at all these different publications, it's all very similar. In the end, they're not so different. So we are very hopeful on the harmonization front there. So, but of course, these standards and these documents state what a utility requires, but not how the information exchange takes place. For that, there are two protocols that we are following at the moment. It's the IEC 61850 and the IEEE 2030.5. To be really honest, the 2030.5 reads very easily, so it's very easy to understand. The 61850 standard is a bit more complex, a bit too complex for us to understand directly. So we've asked experts in 61850 to help us navigate and help us with the translation of the grid codes through through IEC 61850 to the aggregator or the charging station operator in this case. Of course, the next step is, as you may know, OCPP. So we are a great supporter of OCPP, and OCPP in its current form, whether it's the 1.6 version or the 2.1 version, does not cover bidirectional power flow. We've been working on it for quite a number of years now. And the first few years, we mainly focused on the information exchange needed with the vehicle. So the two protocols that we are defining or describing in the OCPP version that we're working on currently are CHAdeMO. That's where we started. And since the publication of the ISO-20 last year, we've added the information exchange needed if the bidirectional power flow is communicated through the ISO-20 standard. And so that part is sort of already very clear, and we're currently adding, and we're almost there, all the information exchange needed when taking into consideration the grid codes. To be really honest, the OCPP part is not really complicated, and so just the information exchange is not that hard. It's mainly, of course, the implementation in the charging station itself that requires most work. So we are planning not only, of course, to publish the bidirectional power flow support in OCPP and the grid code support in OCPP in a version, let's call it 2.1, a future version. But that only describes the OCPP behavior. But as ELAAD within the SCALE project will also publish an end-to-end document with the purpose of educating. So how does it all tie in? And hopefully will clarify at least everything that we've learned we can share to a broader audience if they so like. So just a little bit of a preview. So if you're familiar with OCPP, you can see all these sequence diagrams in the specification. So this is one way of us trying to explain, okay, if these are the messages coming from 2030.5 or 61850, then it translates in this manner to OCPP and to CHAdeMO or ISO 1508 and backwards. So you sort of can see in detail how the information exchange could take place. We still have a lot of open questions, which are very detailed. If you're defining a protocol, of course, you need to watch all the details. And to us, they are questions, maybe to many of you that you already know the answers. So, for instance, with the curves, that it's too much technical details, but you communicate curves that the power generating module needs to follow. What if there are multiple curves? Is there a priority? What if they are conflicting? What do you do? So we can find some references in different documents that sometimes state the same, sometimes have a different statement. So those are the final details we need to iron out before we can publish a very comprehensive and correct standard and document. So if you are working on this topic and you could help us finalize it, that would be great. And it turns out that it's not as complex as we thought. It's very challenging, and we're very confident that soon we can say that the grid codes should not be an impediment to V2G.
Thank you very much, Lonneke, for your clear presentation. A lot of work is done at the moment at ELAAD, but not only at ELAAD. We see some questions coming in. We'll do more questions after all the presentations, do a little bit of a panel. But one question by David was, there are many grid codes by solar PV already on the market which are used. Why don't you just copy them?
Yes, of course. Yes, of course. That's exactly what we're doing. We're not reinventing the wheel. And of course, these grid codes apply to power generating modules, whether that's a wind farm or solar panels, of course, or battery, whatever. It's very similar. So of course, the physics behind this is exactly the same. And that's also the basis, and also the standards that we are using. We are basing it on what's already out there and been done.
Yeah, so actually you're copying best practices from other sectors, for example, solar, into automotive sector, and that's the innovation. Yeah, perfect. Then one question, next speaker is Jeffrey. What is your question for Jeffrey? What is your call to action, Lonneke, for Jeffrey? Well, I think we better just get started with Jeffrey. Jeffrey, are you on the line?
I am here.
We'll do the call. Jeffrey Liu here from the California Energy Commission. We'll do the question, what the call for action from a grid perspective, from a protocol perspective is in the panel discussion. Jeffrey, the floor is yours.
All right. Can you see this presentation that I have pulled up?
Yeah, beautiful orange poppy flowers. Compliment.
Awesome.
I like it as a Dutchman. Go ahead.
Thanks, Baerte. Hey, everybody. I'm Jeffrey Liu. I work in the Vehicle Grid Integration Unit at the California Energy Commission. I want to follow up to Lonneke's presentation with by talking a little bit about grid codes specifically in California and also their implications for vehicle to grid in California. Just a brief note, though, on these flowers. We're rapidly approaching wildflower season here in California. So if you find yourself out in nature enjoying the blooms this spring, please be sure to stay on the trails, leave the area as you would like to have found it, and ensure that other folks can enjoy our fabulous flowers as well. All right, let's talk about grid codes. In California, our grid codes are typically outlined in a document that's called Electric Rule 21. So Rule 21 defines the requirements for generating devices that want to interconnect with our distribution system. These are devices like solar inverters for rooftop solar, like we were just talking about. They also include things like vehicle to grid equipment. Utilities actually maintain their own Rule 21 document. Rule 21 is not some piece of legislation that's passed by the state. In California, our largest investor-owned utilities are regulated by the Public Utilities Commission, and the PUC oversees the utilities development of Rule 21. So that's the long way of saying that even though each utility maintains their own Rule 21 document, the state does have some say over the policies and the requirements that end up in Rule 21. The grid codes in Rule 21 are actually derived from a separate standard from the Institute of Electrical and Electronics Engineers, that's IEEE 1547. So that's actually the same standard that Lonneke had referenced in her presentation. If you actually click through into Rule 21 and open up the document, you'll see that it's hundreds of pages long. And we're not going to talk about the whole thing today. We're going to talk about the portions that are actually relevant to vehicle to grid. And those are the parts in Rule 21 that specify smart inverter communication protocols and also smart inverter certification requirements. So during a vehicle to grid session, you're taking energy from the vehicle battery, you're putting it back onto the distribution system. In that process, we use smart inverters to ensure that the electricity you're putting back on the grid conforms with grid requirements. To make sure that we do this correctly and that we do this consistently, Rule 21 places two main requirements on smart inverters that want to interconnect. Number one, they need to be certified to Underwriters Laboratory 1741 Supplement A, or UL 1741 SA. This is a safety certification that basically checks that your smart inverter outputs electricity correctly and it responds to deviations in electrical conditions correctly. The second requirement in Rule 21 is that your smart inverter needs to be capable of communication using the IEEE 2030.5 protocol by default. Again, this is one of the standards Lonneke had mentioned as well. Rule 21 also says that other protocols could be used. To check that there is this communication capability, we use a separate certification called the Common Smart Inverter Profile, or CSIP, and this is maintained by SunSpec. So all of this is what Rule 21 says about smart inverters generally. Let's talk about what that means for bidirectional charging and for vehicle to grid. With direct current vehicle to grid, or DC V2G, that's actually allowed under Rule 21 already today. In the case of DC V2G, the inverter is off-board the vehicle, it's stationary, so it's treated like any other inverter under Rule 21. So it needs to meet those two requirements, UL 1741 SA, and also the default communication protocol. Typically with DC V2G, the inverter is part of the electric vehicle supply equipment, or your bidirectional charger, basically. When we look over at alternating current V2G, or AC V2G, the inverter is actually located on board the vehicle. So your vehicle can move around, it can go to different utility territories, which means that this inverter could show up in different utility territories and put energy back in different utility territories. Because of this, there are different certification procedures that apply to this automotive non-stationary case. And the short summary is basically that these certifications are still pending. There's no interconnection pathway for AC V2G under Rule 21 today. So with only a couple of exceptions, AC V2G isn't really used in California today. At the bottom of the screen here, I've sketched out the default communication architecture for DC V2G that's implied by Rule 21. So this is the version that's allowed under Rule 21 today. If we start at the very left, we have the utility server. It'll send some control signal over IEEE 2030.5 to an aggregator. That aggregator pushes it along again in 2030.5 to your DC bidirectional charger. Since your DC bidirectional charger has to meet Rule 21 requirements, it's certified to UL 1741 Supplement A. Now, how your DC charger and your vehicle communicate with one another and coordinate that charging or discharging, that is out of scope for Rule 21. Rule 21 doesn't have any requirements about that. So everything up to this point that I've talked about is about what's explicitly written into Rule 21. I want to shift to talking about what industry is implementing and what's happening in the real world, because this is where we start to see a gap. Even though 2030.5 has been the default communication protocol in Rule 21 for many years, the EV and the charging industries have not adopted this communication protocol. So if you do a survey of all the commercially available EV models, you'll find that none of them speak IEEE 2030.5. If you do that same survey for EVSE models, you'll find that very few speak IEEE 2030.5. And this is because the industry has standardized around a different set of standards. They use Open Charge Point Protocol, or OCPP, and ISO 15118. And under this 15118 umbrella, I'm including -2, -20, and to an extent, DIN spec. One nuance that I want to note about Rule 21 is that it specifies minimum certification requirements, but the actual protocols that you use in practice may differ from the Rule 21 defaults. So in other words, even though 2030.5 is the default protocol in Rule 21, your actual installation at a customer site may rely on other protocols instead, particularly if you're going through an aggregator and you're not communicating directly with the utility server. What this means is that even though there's this gap that we've identified at the top of this slide here, there is still a pathway forward for V2G using the EV and charging industry's preferred communication protocols. In fact, there are pending industry efforts that'll update both 15118 and OCPP to support grid code communication and to help them meet Rule 21's technical requirements. So that's the OCPP 2.1 that Monica was talking about earlier. I want to point out that 15118 and OCPP are globally aligned protocols, meaning that they're used by automakers, charging providers, charger manufacturers, and so forth all around the world, including North America and the United States. Because of this, because these protocols are used globally, these updates to them can help support lower barriers of entry for V2G implementation and also global economies of scale. So if you put together everything that I've talked about, what I'd like to propose as an idea for industry to further explore is that these updates to 15118 and to OCPP, if paired with regulatory acceptance, this can help break through a V2G stalemate that we see today. Right, today, everybody talks a big game about V2G, everyone's excited about V2G, but the fact of the matter is the barriers to implementation for V2G, both from the manufacturer perspective and also from the consumer perspective, are very high. And as a result of that, you see what we have today, which is a lot of excitement about V2G, but very few actual products that can help the customer do this in real life. These ongoing efforts to update these protocols can help lower these barriers. So the updates to 15118 and OCPP are likely to be especially impactful for alternating current V2G, because they're going to add grid code communications to these existing globally used protocols. But even if this work completes, meaning those 15.11.8 updates, the OCPP updates, they're published, that alone is not enough. In order to actually chart forward an interconnection pathway for AC V2G in California, we need a regulatory framework to support that. So Rule 21 would need to accept this approach with these protocols. UL certifications would need to accept this approach with these protocols, and same with SAE standards. In this diagram I have in the middle of the screen that says possible globally aligned AC pathway, you see that I've included OCPP and 15.11.8 in there because they're the globally used protocols. But I've also highlighted UL with a question mark and SAE with a question mark within those green circles. And this is because the certifications and the standards to support this communication approach are very much an open question. But this is something that industry can discuss if folks think this is a worthy path forward. The updates to OCPP in particular are also going to help benefit DC V2G, and that's because charger manufacturers and charging networks all around the world, again, including in North America, already use OCPP today. So if OCPP adds V2G capability into their protocol, that means all these existing charging providers can add V2G capability into their existing systems fairly easily. So overall, my goal today was to lay out the facts about where we are in terms of grid codes and V2G, to point out that there is a gap that exists today, and also to propose a possible path forward that our analysis suggests yields the greatest global interoperability and also the greatest global economies of scale. We want industry and of course other stakeholders to start thinking about this, to start openly discussing this, and to help work with us determine the next steps that are appropriate and in which venues to take those steps if this is a path that we want to pursue. That's all I have. Happy to take questions now. We also have questions at the end. If you have any questions after the webinar, feel free to shoot me an email. Otherwise, thanks for your time and thanks for your attention.
Thank you very much, Jeffrey, for the clear presentation and reach out to the V2G community. Of course, feel free to drop your questions in the chat. A lot of them are coming in. We'll do some afterwards during the panel, but one for now. You mentioned the breakthrough through the stalemate on the V2G, and that regulatory framework is a large enabler for this. You are the regulator, so is this a question of, well, weeks is maybe too optimistic, but is it months or years, or shall we see the first vehicles come to the market and then regulation lagging? What's the time path?
Yeah, well, I'm one in the regulatory community, but not the only one and not the only agency. I think CEC has a role in this. The Public Utilities Commission has a role in this in helping define Rule 21 requirements. But importantly, our work doesn't exist in a vacuum. We point to standards, we point to certifications to ensure that there's that trust that is built into the system. And so we need those bodies to come along with us as well. Those processes take time. This is not exactly the most exciting work to put together a standard. So I don't think this is a weeks or months thing. This is definitely, we need to start talking about this now if this is a change we want to make, and then start treading a path forward.
And on the other hand, the time you're taking also allows people to join this legislative process. So yeah, thank you very much. Then we go over to the third presentation. We're switching over to the grid operator, PG&E. Chris, are you there? Welcome.
I sure am. Can you hear me all right?
Floor is yours.
Okay.
I can see your presentation, maybe. Yes, go ahead.
Okay. So quick introduction. I'm going to talk a little bit about our perspective at PG&E and what we've done to jumpstart V2G, more from a pragmatic, rolling up our sleeves and getting our hands dirty kind of perspective, maybe a little less from standards. So what you're seeing on our screen here is a set of pilots that we've engaged with OEMs and with the Public Utilities Commission, with General Motors, with Ford, and building on the earlier pilot work we already had with BMW Group to do V2G testing and V2G enablement. It's also worth noting on the right here that the CPUC has worked with PG&E to release up to $11.7 million of vehicle-to-grid incentives, which will be available to our customer base in the form of money off of a V2G charger. So that can be $2,500 to $4,000. So that's something exciting and worth looking into in the future if you're in our territory. So at the start of looking into V2G, we really realized that we're talking about a nascent technology which is only kind of half here. I think we have vehicles, we have batteries, we have chargers and connectors, and in theory it should work, as you've heard in many of these presentations. But in reality, there's some big barriers to actually tying that out, not only across the industry itself, but also when it meets the electric grid and doing that safely, doing that in a repeatable way, and getting, quite frankly, our business systems up to speed and our thinking up to speed with V2G. We didn't want to be a blocker to V2G, and we wanted to be an enabler. So one of the first areas that we recognized we needed to focus on was on the California grid, vehicle to home, and home backup is a huge part of the value proposition for V2G. Unfortunately, the UL 1741 standard really focuses heavily on-grid performance, and off-grid performance is not underneath a UL standard. There's this unique point in time where there's a transition between on-grid to off-grid, and that's an area where our distribution planners need to see a little bit more on how that safely happens and how that energization works. So we took out a set of pilots and started looking into island transition testing. So how does the vehicle behave as you transition from on-grid to off-grid? What happens if you lose communication to the transfer switch? What if it happens if there's a mechanical failure in the switch, etc.? And those things aren't very glamorous, but they're real actual safety concerns and considerations that we've seen in energy storage being issues when we saw electricity on lines that were not supposed to be energized, for instance. And so getting ahead of that was something we wanted to focus on. We also felt a focus on island power quality, even though technically when you form your own grid and you go off grid, that's not in the utility purview. But because we have a good understanding of what power quality should look like, what is best in class, we felt that we could add value there to make sure that the customer experience was something that we at least understood end to end, but also could potentially help OEMs and EVSE vendors on better understanding what power quality could look like. So once we got past the safety aspect, we then began looking into the communication between the vehicle and the EVSE, our charger. And this is not normally an area where the utility would participate in. We really stop at the AC side, at the grid side, and we don't usually go into DC communications and DC power flows. And the reason why we got into this portion was simply that when we started this project, there was no interoperability and no commonly defined way of actually communicating across CCS1. And so we began working with our OEM partners. We identified a couple of behind the meter bidirectional EVSE partners. And our focus was really on single phase inverters. So this would be home backup and the ability for homes and homeowners to use the light duty vehicles. And this is a little bit different than what we had already seen in the industry, which up until this point in time was a focus on commercial. What we found as we were going through this process at the time was that the ISO 15118-20 standard was not ready for market. It was still in draft form. And I know since then it's actually been released, but there's still some questions around unit tests, requirements of vehicles and the hardware to support it, etc. So the path we took at that time was actually to look at the existing bidirectional DIN 7121 specification, which is the fast charging specification and the handshake that happens between a fast charger and a light duty vehicle when charging. And what we realized in coordination with our charging partners was that we could update the DIN 7121 methodology to include negative power flows and to clarify some of the unique bidirectional issues such as pre-charging. So in the case of a normal DC fast charging session, the EVSE always pre-charges the DC bus. But if you're in an outage, there is no grid to pre-charge the DC bus. And in that case, you would need to pre-charge from the vehicle. So how do you do that? So there was a lot of just like practical problem solving that we went through, and we worked with the SAE to update their J2847-2 specification to share this knowledge and to actually allow that to be an adopted form. The benefit of this method is that existing vehicles which support DC fast charging sessions, which is most any EV, would be able to actually participate in V2G with only a software update. So there's no need to update the computer in the car or add TLS 1.3 security like in the ISO standard. Longer term though, I think we all agree the ISO 15118-20 is really the future. And so we've begun work on figuring out how to harmonize between J2847-2 and between the ISO standard. So again, you're hearing multiple protocols, multiple ways of doing things, and that will iron out over time. But this was the path that we took, and we were able to successfully discharge with our partners using this method. And the third kind of focus we had on is interconnection field pilots and programs. And so this has been covered a bit by Jeffrey and others. We really spent time making sure, and this is the least glamorous part really, spent time making sure that our interconnection system worked. We explored, is there a way if you're only doing vehicle to home backup that you can actually avoid interconnection so that you don't end up in a queue in a long process, taking time and spending fees. And then we moved on to our actual field pilots, and I'll jump into that right now because we have some key learnings out of the gate. We're not done with our field pilots yet, but there's two key challenges that are already emerging. So the first is this interoperability. I touched on it. In reality, even with the ISO standard coming out, with the SAE standard, most of the solutions we're seeing are still proprietary, right? Charger X with vehicle Y, often and potentially in a package. We're also seeing that the ISO standard and the SAE standard, they're nascent. So while they do work, all the unit tests might not be written. Vehicles have not been tested to work across EVSEs, and often vehicle OEMs are not interested quite yet in supporting that bidirectional communication. So there's a lot to work through there, not only on the protocol side, but also on the OEM side. There's also no requirements to support V2G for the OEMs or the EVSEs. And the testing of this island transition safety is still a one-off process. I think that we'll see some additional benefits in incorporating the CEC and the state in that in the future. So really, to help knock through this, we propose 4 solutions. The first is a form of lab space for V2X testing. So this could be a collaborative approach where multiple OEMs, multiple EVSEs can all come together, do the safety testing that's needed, and do the interoperability testing that's needed. Right now, an OEM would need to go pay to do a test with an EVSE and find a location. And really what we need to do is create a space where all of this can kind of come together. The second is for the CEC to start maintaining an inverter list. They already do this for solar and storage inverters. There could be a huge benefit to also leveraging that already proven register and database to expand that into V2G. The third area that we can improve on is really for our V2G incentives going forward to require interoperability and to require non-proprietary solutions. We're not there yet, but I do believe over the next 10 years, as we see more and more programs, that interoperability needs to be key and core to what we advocate for if we're going to be spending state and ratepayer funds towards that. And lastly, exploring pathways for V2G capability to be enabled by default. What would it mean for every car to support V2G out of the gate? So lastly, I want to touch on the second challenge we're seeing, which is really the cost to install. What you're looking at here is the 6 customer vehicle to home pilots we undertook with the 2 manufacturers. And I think what's most illuminating is to look at the charger hardware costs. You could consider that the V2G technology. in the actual cost, when you add in the electrical labor, the panel boards, the load relocation, the cost can often be only 25% of the cost being actual charger technology and 75% being labor, wires, and others. So I think this is highlighting that there's a big gap between the technology and what it takes to implement it. And we're going to need to look to continuously push down this cost and find better ways of connecting this to our system, because this type of spend where you're putting 75% of your cost on wires and load relocation, none of that moves society forward, and none of that moves V2G forward. That's really almost a tax on being able to get the technology in. I think last but not least, the elephant in the room is this big bar on the left, 58,000. What we found is there's a portion of customers on the network who have 100 amp panels, 100 amp services, and those need to be upgraded to be able to support even EV charging at all. And sometimes the cost to actually upgrade the wire, if it's underground across the road, requires a permit with the city to dig the road up. It can be astronomical. So we really need to double down and find ways to make sure that the EV transition and the V2G transition are as seamless as possible, and find solutions to these problems that are not just throwing money at the problem. So that's what I have on early insights. Thank you for letting me speak. Feel free to shoot me an email if you have any questions after the presentations. Thanks.
Thank you very much, Chris. Being a grid operator myself, I recognize a lot of the challenges you face in California. And have imagined the first slide of Lonneke with all the cables. It was a picture of Utrecht, but I can imagine that's roughly the same in California. Not very glamorous, as you say, but it has to be done because we all appreciate 24 hours of light when you turn the switch on. A question, some questions are dropping in regarding vehicle to home or vehicle to grid. Is it a linear path that you first have to do and control vehicle to home, and then you can go to vehicle to grid, or are they aligned? What is your vision on that?
Yeah, that's a good question. So actually, if you were to do vehicle to grid only and not have any home backup, so during a power outage, you don't separate from the grid, you don't form your own island, you don't have home backup, but you only did grid interactive vehicle to grid, this solution would actually be much cheaper than doing vehicle to home backup. I think in Europe, where the grid is more reliable, maybe there's more of an appetite to doing vehicle to grid only without the home backup capability. But in the USA, we've largely seen from the customer base, I have a battery on my home, I have an unreliable electric grid, why can't it power my home? And so in effect, we've seen vehicle to home be kind of a bit more of the leading reason why customers get into the V2X space. And I don't see that changing. I just don't think for the average consumer, when they buy an electric vehicle, they're really thinking about the electric grid and their electric profile. I think they're thinking more about the reliability, I can power my home, and these kind of things. And that's really maybe a cultural difference between Europe and the US.
Yeah, thank you. And maybe for the not grid operators in this call, you mentioned a few times the importance of anti-islanding. Why is that so important for grid operators?
Yeah, so anti-islanding is the function essentially where if the electric grid goes down and there's enough solar, battery storage, or electric vehicles feeding the grid, that they need to be able to detect that the grid has gone down and they no longer feed power back to the grid. And from a utility perspective, this is crucial. You know, if the electric grid goes down, or if we need to shut off an area of the electric grid, these systems need to be able to detect that that has happened, so that there's not unsafe energization across the lines. Fortunately, anti-islanding has been in the specifications for 20+ years. That's much less of the issue right now. The larger issue is because these systems can do home backup and can energize a grid when they're disconnected from the grid, we need to make sure that the system is aware that it's been separated from the grid and that it's done that in a safe way so that it doesn't try to energize into the grid thinking it's disconnected when it's actually still connected. And so we've seen in the California market actually an instance where a home battery system thought it had left the grid and tried to start its own home backup, but in reality energized the electrical circuit. So nobody got hurt in that scenario, but it was really maybe one of the first times where, you know, the utilities were looking at that and were like, wow, this is really actually a vulnerability.
Yeah. And this is important for all grid operators all over the world, but regulated on slightly different ways. So there's an opportunity to align that. Thank you very much for this moment. I think we're going to the next speaker, Sebastian. You are working at Lucid, a car manufacturer, on bidirectional charging. The floor is yours, and maybe in your presentation you might highlight a little bit on AC/DC, because some questions are coming in and on the chat as well on that topic. Feel free, go ahead. You're muted. Right. Yes, now I can hear you and I can see your screen. Yes.
Wonderful, thank you. So yeah, in fact, I want to share some thoughts with you from an OEM's perspective and also from a customer's perspective. And as you mentioned, we would dive a bit into the AC technology. But let's first start with how customers would interact with the system. So I want to build up with you a set of use cases seen from a customer's point of view. And the customer here is a human who purchases a car. So it's not yet a business or a grid operator. It is a person who owns a car and uses that car, maybe charges at home. And you start with just having unidirectional charging. This is simply charging your car. It can be optimized based on time of use, tariffs, or it can be V2G, grid aligned, grid optimized, but it would remain lonely charging process. Now we add bidirectional charging to this, and this spreads into, technically seen, into two buckets. One is use cases which are grid following. You would discharge into a grid which is live. And with that, you can do behind the meter optimization.
Sebastian, sorry, yes. One remark, maybe check your presentation because we only can see what appears to be the, yes, that is better. Yeah.
Oh, you should see the full screen now. Don't, oh.
Now we see a white page. Now we see,
here?
Yes.
Ah, thank you. Thanks for letting me know. All right.
Next, so for interrupting you.
Sorry. Don't know what that was. So here you see use cases using a live grid to power into. You can do local optimization behind the meter, which all happens on the premises. That is load shifting load from on peak to off peak times, or demand charge mitigation, where this would be more a business use case. And then you open up the landscape for grid services, where the vehicle would push into a grid which is live and support the grid, contributing to a virtual power plant or to a demand response program. And then the other bucket of bidirectional use cases is making use of grid forming, let's say architecture, where the grid is down, you're isolated from the grid, and the vehicle is the voltage source, or the vehicle together with the installation is the voltage source to that island. And of course, that includes the backup power use case, which brings you peace of mind at home. But it also includes rolling outages where grid operators kind of create outages to reduce load on the grid, which we like to be shifted up here, where this happens less often, whereas it gets compensated with vehicles actively pushing into the grid, supporting grid stability while still being connected without artificial power outages. And again, from a customer's point of view, it's both use cases in the grid following mode as well as in the grid forming mode. So one message here is the request to find a holistic approach to them both, see them in combination, think of common architectures, and think of common certifications and communication protocols. So this would enable us to interoperable systems which are adapted by customers and lead to a harmonized user experience for customers. So what we see today often is a view on either or. So a view on grid interactive discharging or a view on grid forming. And the request here is actually to always think of both. And this extends the thoughts of the other speakers. And Chris did also bring this up, that this is something which we should all work together to enhance this thought on things. Now, the next slide I want to share with you dives into AC-DC differences and different architectures around that space. So basically, the car needs to be charged and discharged. So it's two things, and both ways can be either AC or DC. It gives 4 combinations, and we'd like to dive into them. Oh, what happens here? Something is tricking me here. Can you let me know what you can see? Can you see this slide well?
Yeah, we can see it, Sebastian.
All right, good. Sorry for that again. So if the car is AC charged and AC discharged, that brings us to this setup here, where you would have the car with an onboard charger, which is enabled for bidirectional charging. So it is charging the car and acting as an inverter. You would have an AC bidirectional charging station, which many people have at home anyway to charge at level 2. And if you want to support the islanded use case, you would have to add a separation layer which securely isolates you from the grid. But if you're not interested in that use case, you can leave that out. So another architecture is a pure bidirectional DC-based solution where the car would be DC charged and DC discharged. So in this case, obviously you need a bidirectional DC stationary charger, which has the rectifier and inverter built in. And the car would be connected using this connector where you would leverage the DC pins, obviously. So we have a bit more bulky connector here. But besides that, it's pretty similar. You can think of such a hybrid system where the car is AC charged and DC discharges. So this requires the charger to be such a hybrid solution, and you would somehow make use of an existing or a new additional stationary inverter, which would be needed on premises. And here, the connector to the car would need to have populated the AC pins and the DC pins. Now, some of the differences here are highlighted below. So the pure AC setup can be seen as the leanest setup. It imposes the lowest cost because obviously an AC charger is a pretty simple design as compared to a DC charger internally. And it's therefore scales well into large rollouts. And it can also be quite customer friendly because customers have this already and the installation cost may be quite affordable. So however, then the challenge here is that as the inverter is on the car, it needs to obey the local grid codes. So the car could be somewhere else tomorrow, right? So this is a dynamic thing. Whereas here at the DC discharging setups, where the car would DC discharge, this challenge is avoided by having a stationary inverter. And this is the main difference between AC discharging and DC discharging. And the suggestion is to also think of AC bidirectional, AC discharging, in addition to the other setups, where we would then be able to leverage those advantages. So a lot of discussions happen around bidirectional DC or DC discharging currently because of the reasons given. However, we want to dive into the AC path a bit deeper. Just to complete this, this fourth combination is not really seen on the market. If somebody has an idea, raise your hand. So let's now dive into architectures for AC bidirectional, mainly AC discharging, but in this sense, it's bidirectional AC charging. So there can be different system combinations, and we have units today deployed in the field, and we are working on standards to move into an interoperable scheme where more flexibility is enabled, roaming scenarios, etc. But today we don't have that yet. So what we have today is existing EVs and existing EVSEs, which are in the field, and they can be bundled into those two different systems. So you could bundle an EVSE and an EV, constitute a system out of them to enable grid following AC discharging, or you could add an MID, kind of a gateway disconnecting from the grid. This adds the grid forming use case. So this would bring all together what customers want. And the suggestion here is to leverage the existing units in the field, both EVSEs and EVs, to form systems which for the time being are treated as units, closed systems, which are seen as one new instance to meet functional and safety requirements. So it would be systems and not inverters we are looking at here. We would look at a system which is a coupled new unity of those individual devices to capture everything which is in the field. Now, as the standards progress, and it's our all's duty to influence standards evolvement, safety certification evolvement, and Route 21 evolvement, where this should lead to is a scheme where you enable true roaming solutions. Any EV can meet any EVSE, so you would break this closed system. This, of course, needs them to communicate, and also grid codes need to be known by the vehicle. Now, the question is the EVSE relaying them? Does the EV find them out by themselves, covered by the other presentations you've seen today? So it would be this use case here. For example, UL 1741SC is working towards such a setup. However, there is also this combination where you have EVSEs and EVs, and you have an MID to enable backup scenarios, grid forming use cases. And for this, I'm not aware that any work stream is really addressing such setups, or maybe them all together, where again here, the suggestion is to unify the view on grid following and grid forming, and also care about the transitions between them to enable a holistic customer experience. So this approach, if we combine them together and we address this as the challenge for us all to solve, we would enable a holistic solution for what customers really want and need. We would integrate great interactive and grid forming use cases, and we would carefully consider transitions. Maybe they can be flicker free. What if the vehicle is sleeping, which is now supposed to be a backup source, needs to be woken up first? It's maybe difficult to enable a flicker-free transition. But besides that, if it's alive or for the transition back to grid power, it can flicker-free. This would be highly interest to the customers. And from an OEM perspective, OEMs deliver solutions for a worldwide market. There may be a rollout scheme, but in the end, the vehicle is slightly adapted to different markets. So it's highly attractive to think in global solutions as much as possible, with, of course, obviously market-specific adaptations. But if at least the standards, the communication standards, the format of data formatting is harmonized, that is a huge advantage. And this could be a huge shift, a huge push for us all to bring this technology into the market. All right, those are the slides I had. Now, some key takeaways from this, just as a brief summary. Let's consider grid interactive together with grid forming. Always discuss that together because customers want both. See the AC technology as something with a huge scaling potential. We discussed that. There is less installation costs. And Chris, you touched the point where you summarized installation cost for some reference prototype setups. So if you say customers have an AC charging station already, and you need to add a few things like the disconnect device, it can be fairly straightforward. Think in systems and not inverters. Allow a thought that you bundle systems into a closed new entity and certify that regarding safety, and allow that to appear as one unit as a grid resource. By doing that, enable existing fleets to participate because you would include vehicles and EVSEs in the field. And of course, try to find global solutions. All right. Thank you very much.
Thank you very much, Sebastian. A lively presentation, and the chat was also quite lively. There are some questions dropping in regarding making money out of it or saving costs. There are some questions regarding frequency control. So I know in Europe, enabling frequency control with the battery of your vehicle, you can make a lot of money. But in your presentation, this is only done for V2G and not for V2 Home. Is that so, or does your vehicle in future also allow frequency control at V2 Home?
Well, the use cases I presented earlier, that has just been an example. I'm not saying this is what Lucid is exactly up to. This is, I mean, use cases which we are all together discussing. And of course, frequency regulation can be seen as a grid following use case. So there is a live grid, obviously, and you support the grid. I would say this is kind of a grid service. So you could think of frequency control as one use case here related to demand response in VPP. So you're creating value for the grid with bidirectional charging on the premises.
Yeah.
While the grid is live.
Yeah, and before we open a panel discussion with the other participants, there was a question also regarding frequency control or services by Christian. He said, what's the speed of flexibility? How fast does the vehicle has to respond on a grid demand or vice versa? What's the frequency of the frequency control?
Well, this is a very frequency control specific question. So for these, for all these use cases, the question is which quality of service is required, which is the latency which needs to be met, and there maybe also be a variance, like you can do frequency response with a short latency, creating a higher value as compared to with a lower latency. But this goes into modeling the value chains. And with all those grid services, of course, value is generated. They would support a grid in its stability. So there is value created, and the value can be shared among the value chain and the stakeholders, right? But this is up to the business participants to create customer products around this, and then also discuss how incentives are shared. Now, this is something I would say this is the business aspect of the landscape, whereas the imminent challenges I see on the technical side, certification side, and getting approval, getting listed, and getting interconnecting permission for these use cases.
Yeah, and the permission, it would help, in my opinion, for your business if this would be a bit standardized, harmonized on certain ways.
Yeah, we see a certain level of fragmentation and evolution. So if you dive into this slide here, we know how to handle stationary inverters. They are there for stationary storage, for solar to grid. I mean, we all know how this works. So, and then these two DC discharging solutions, they don't care about the path to the vehicle. They start here at the stationary inverter. So what is missing at this point is to open this landscape and allowing the inverter to be on board. Whereas this could be an existing car in the field, whereas the charger also could be existing. And then thinking of this as a system and treat this system comparable to an inverter as compared to the stationary inverter architectures. This is something where we can join forces to enable such solutions, because this is highly in the customer's interest, and it enables a lean setup with a huge scaling potential, I believe.
Great, thank you very much for this.
Thank
Jeffrey, Monica, and Chris, may I invite you also to switch on your camera and join for a joint discussion. Chris might also participate. Maybe some reflections, Monica. The call for action by Sebastian, his last comments were, we should do this together. Could you reflect a little bit on that statement? Is that possible to do this together?
Yeah, so I think yes, and maybe I will have to eat my words in a couple of months' time. But as a background, I'm an electrical engineer. So whenever someone says that there are so many different grid codes out there, as an electrical engineer, I sort of wonder, because the electricity grids is more or less the same all across the planet. It's either 50 hertz or 60 hertz. It's 230 volts or 110. It's one phase or three phase, but there's not a lot of difference, and the physics behind it is all the same. So I would be really surprised if there is something fundamentally different that utilities in Korea need as opposed to in India or the Netherlands or in Colombia. I would be really surprised. I do. The utility market globally is of course very fragmented. There are thousands of utilities across the world. There is great consolidation already ongoing countrywide, and particularly with the California Rule 21 and the great work done by IEEE 1547. But I'm confident that we can make it as easy as possible for parties who want to implement V2G, that at least from that perspective, they are well equipped to address all the utilities requirements with one implementation.
Yeah, Chris, I see you smiling on the comment of Lonneke. Is that?
I just think the V2G dream is great. It's just like there's all these little nuts and bolts. And I was speaking the other day on a conference panel, and someone got up and said, "Yeah, it's all gonna happen in 10 years. Like all of this is gonna happen." And it's like, it's true, but it takes all of this coordination and going through all of these little parts that we've said are not glamorous to like actually make it happen. So between saying and doing is really large, but yes, conceptually it will all work.
Yeah, and are you? Yeah,
I mean, joining forces is maybe the key here. It is about creating the standards which measure functional safety. It's about defining the use cases themselves, establishing a joint view on things like grid forming, grid following as one joint thing and not diverting them into different buckets. And then following the path towards legislation or the government bodies or the supervising bodies like the CPUC, working with the utilities to allow and enable such innovative interconnecting architectures in their respective documents like Rule 21 and their variances of. And then, well, this may be something California specific. We like to see a path how this rolls out to the whole country and the whole continent and the whole world. But then at some point, legislation is different in different continents and different countries. So maybe it will diverge there. but the more we can join together and pull on one string, the better we can do here.
Yeah, thank you. I know an answer for Europe on this question coming in. It's about a test lab and implementations. I'm sitting here in the Dutch e-mobility test lab for charging. But Stephen is asking, would it help collaboration to have a larger facility in the US to test implementation of vehicles and standards and charging stations? Jeffrey, may I address this question to you?
Yeah, I think it would. I mean, Chris had pointed this out with one of his later slides. And I think Sebastian, to a point, had hinted at this too, where he had that slide of like, how do you achieve this wonderful interoperable future among those islanding devices, among your chargers, among your vehicles? You know, just anecdotally, I think folks have talked about the need for this many times. If you go to like a Turin festival, everyone's like, why don't we make this permanent? And so I think the desire is there. So far, we haven't seen industry, you know, act on its own to create this. So there's definitely some interest at the state level of seeing what levels of support might be appropriate here. But I think, generally speaking, a collaborative space where folks can, yeah, in a low risk, safe environment, test with one another, I think is very valuable. And maybe I'll turn it to you a little bit too, Baerte or Lonica, and you can talk about ElaadNL's work in this space.
Yeah, Lonica, this one is for you.
Yes, sure. So as Baerte mentioned, we have a new test lab in the Netherlands. And the work that we will be doing there mainly is with the ISO 15118-20 standard. And of course, it is, everybody I think knows, it's a complex standard. So we are also investing in test equipment, so we can really see the detailed logging and do all the communication testing there. But also the anti-islanding and all the other safety testing we will be setting up there. We are still learning, it's all very new. And that's why we're so glad to cooperate with all these different parties to learn this together and test it together. And of course, under the great cooperation we have with you over there, we'll of course share that. So what we learn where we fail, we will show you where we have failed. And where we succeed, of course, we'll share as well.
Yeah, and this is needed. There's a question by Christian Peter. How far away in terms of time are we with wide availability? Well, Chris said, well, maybe 10 years, but you started with a project called Scale in Europe. There are some car manufacturers involved in that as well, isn't it, Lonica? So it's not 10 years away, but maybe a bit earlier. Or Sebastian, when is your vehicle ready?
So the question is for me?
Both.
All right. So, I mean, that question goes to every individual OEM, right? We see a huge momentum currently in this space. You can see this by reading the announcements OEMs do. The Lucid vehicles are prepared for these use cases. So we really believe this is a momentum. And we also see other OEMs pushing into the same direction. So it is really, it seems to be the consensus of current times that we all want to do this. We want to leverage the vehicle as a grid resource and do something good for us all.
So not a date, not a time for a release, but it's coming soon. And not only for the American market, but the global market. Is that correct?
Well, yeah. I mean, I can speak for Lucid. We are selling vehicles since a year and a bit, and we are rolling out into other markets. So we did roll out into Europe and other countries. Other OEMs have a footprint which is globally since 100 years. So this is something which will have a market-specific aspect, it depends on what the customer value in a specific market would be. But certainly it's North America, it's Europe, and many more to come, I believe.
Okay, great. I think we're going to the last questions. There are many questions regarding this webinar. It is recorded and it will be shared by the California Energy Commission and ELAAD later on. We'll try to respond on every question stated in the chat. I'll do some last questions. One is on vehicle battery warranty. That's a question we always have on each conference. How about the batteries of Lucid, Sebastian?
I mean, of course, there are warranty considerations. And the task is to care about different aspects of implications a use case brings. So if value is generated by cycling the battery additionally, this is what the system earns in the interest of the customer. But of course, additional cycling to some extent degrades the battery. That cannot be ignored. The question is, what is the battery designed for? What is the warranty term? And which limitations are reasonable for these use cases? But there are use cases which have a massive value they create as compared to degradation cost. Now, this is also something every OEM would carefully model and find the right way to approach the market. And if you think of use cases like backup power, I mean, it's peace of mind. It doesn't happen too often, hopefully. In some regions, it happens quite often. Like in the Santa Cruz Mountains, it's normal to live with outages. So the value can be, it's an emotional value people gain, and peace of mind and safety for their families and their home. This is something where you don't really trade that against battery degradation.
Thank you very much. That was about the profits it might end up. Still some questions are coming in. One regarding electrical safety. Well, Chris mentioned some things regarding anti-islanding. It brings to my mind we haven't dropped the question regarding cybersecurity, which is also very important for the Dutch grid, but possibly also in California. Still, questions are popping in all the time, but I think this might be a nice momentum for some closing statements, because everybody, you have to start your day in California, and we have to start our evening. So what is your conclusions, or what will be your next steps? Chris, may I start with you?
Yeah, so I think leaving off on kind of the last slide I had around cost, and the dream is maybe $4,000 or $5,000 to get V2G. The reality is $15,000 to $20,000. And so I think the OEMs and the first generation hardware, in large part, they own some of that. And also as the utility and the steward of the grid, we own some of that. And so I think the next year or two, we need to attack aggressively the way we connect these to the grid and how we structurally reduce cost out of the solutions. So I think that's one area that really needs some work. And I think another area that we should explore more is to figure out through legislation what is the appropriate level of legislative oomph behind what we're trying to achieve in California to get to our state goals for clean energy. Is it mandating V2G capability in all vehicles sold in California? Is it something maybe a little bit less? But we should start to look into this a little bit more, because we have a constrained grid already. EVs coming to the grid are going to exacerbate that, and we're going to have to spend money. ratepayers are going to have to spend money to essentially enable this transition. And should they also be paying again on the back end to access the battery, to access this capability, to solve the problem? So I think those are things that we need to think through, and coming with a comprehensive strategy around how we get aggressive on costs and how we get aggressive on capability, I think is what's going to be the difference between having V2G in a form factor people want in 3 years versus in 10 years.
Perfect. Thank you very much. Sebastian, what's your call to action?
Well, I have many calls to action. Let's join forces. Let's harmonize the view on grid interactive and islanded. Let's care about making the transitions smooth. Let's think in systems and not inverters, allowing systems to be interconnected, listed, certified, and be treated as safe in a unity. And then let's try to find common communication architectures. We all have learned the history of charging protocols has not always been such that this world is just working on the same standards and deploying the same standards. We have another chance now to join forces and to create one solution for us all. That makes life easier for all of us.
Yeah, so not a system transition, but a transition of systems. Nice. Jeffrey, Chris, for example, said make it mandatory on a certain level to speed it up. What's your uptake of this this first webinar together with ELAAD on behalf of CAC?
Yeah, if today mandatory, I don't know that CEC is ready to do that, but I think we do look at this in like two main lenses, right? Short, medium term, and then longer term. So short, medium term, CEC is going to help deploy a lot of funding into this space. We're going to help try and buy down the cost for consumers. We're going to help deploy funding so that manufacturers and charging providers can implement the standards, try and get this interoperable, try to get this functionality in to begin with. But then longer term, I want to harken back to my presentation, and there's this gap. There's a bit of a stalemate. There are a lot of uninteresting but important problems to solve in the communication space, and those need to be translated into standards. So if you work in a standards body, you're a company that attends standards committees, and you want to help solve this problem, reach out. Let's chart out next steps together on this.
Yeah, great. So midterm, kickstart the market by some funding, learn best practices, and in the end might regulate it or mandate it. Thank you very much.
And just to clarify, I didn't say we should make it mandatory. I said we should explore what the levels of legislation and tools we have to get to the goal that we want to get to is. And if that includes making it mandatory because that's what we need to motivate the OEMs, then we should explore that. But I'm hoping that there's other solutions in between. It's just the traction has not been as immediate and as present as I think we need to hit California goals.
Yeah, and I think that's also what participants here are saying. We must learn from each other, from different sectors. The automotive must learn from the energy sector and vice versa before you make that next step. Is that correct, Lonneke? Closing remarks are for you.
Okay, thank you. So Baerte, so I think, of course, we're really excited about V2X, making this happen. And from the ELAAD perspective, we'll do all we can. So on the one hand, help with get more clarity on all the different grid codes and try to harmonize them to make it as easy as possible for the market to adhere to all the grid codes all across the world. Secondly, of course, through the work we do with the Open Charge Alliance, make sure that the next OCPP version covers these functionalities also very clearly and very globally. And thirdly, offer our test lab to do all the testing that's needed. And with these three elements, we'd like to contribute moving this forward. And of course, inviting everybody to join us either with getting the inventory on the grid codes, joining the work at the Open Charge Alliance, or help us with testing at the test lab, where we invite everybody to help everybody get there.
Yes, and regarding this last thing, that's quite tangible, isn't it? Because there's an event planned in March.
Yes. Oh, indeed. We have the next we have on March 28th. We have a V2X webinar live at the Elaad facilities in Arnhem. So if you're able to travel there, yeah, please do. It will be a very nice week. The days after, 2 days after, there will be the OCPP Plugfest, so you could also attend that. And during the whole week, we will be the host of the IEC 63110 working group, who have their face-to-face meetings. So a lot of things happening in that week at the Elaad test lab. So if you're around, yeah, drop by.
Yeah, great. Thank you all. We'll try to give everybody who chatted with us with questions to respond by email. But also feel free to join us in March. We'll have not only an hour and a half, but a whole day of debating and discussing and exploring new possibilities or identifying challenges and barriers to overcome. Thank you all, my panelists, for this very interesting hour and a half of talks on bidirectional charging. Thank you all for the participants, and we hope to see you either in March or at any other conference or task lab working on vehicle to grid. Thank you very much. Bye-bye.